Hi everyone, my name is Matt. I'm one of the lead maintainers of Dask, and today we're going to talk about the challenges and opportunities of deploying Dask at scale. So this argument usually falls into sort of three easily identifiable sections. First is a library like Dask makes parallel algorithms really easy to run. It provides things like parallel pandas, parallel NumPy, parallel machine learning libraries, parallel other stuff. But there ends up being a lot of additional IT challenges that get in the way of being productive. These are things you wouldn't normally anticipate. There are things like, well, how do I build Docker images with just my right set of libraries? Or how do I make things secure? Or how do I invite team members and manage their usage? These things are annoying, but they end up actually stopping a lot of progress. And so we've actually focused a lot on them in the last couple of years. And then third, usually in this sort of argument, there's some sort of sales pitch at the end. And this talk is going to be no different. I'm going to talk about Coiled, which is where I work. And we're going to try to show how we have solved these problems. I'm actually going to skip the first section. I'm not going to talk that much about Dask. I've given, I don't know how many talks about Dask in the past. I and others have recorded talks that are available on YouTube or other sources. If you haven't heard about Dask, I recommend watching one of those first. I'm going to assume that you know what Dask is and that you already want to use it. Maybe you've used it on a laptop. Maybe you've seen some cool talks about it. Maybe you're trying to scale out and you're curious about how to get started. This talk, we're going to talk a lot more about the IT challenges, but what it takes to actually get up and running on real hardware on the cloud or elsewhere. And we're going to focus most of our time there with a motivating example. At the end, again, I'm going to give you a punchline or a solution. That's going to be Coiled. And I'm going to encourage you to run these 3 lines of code, which will run a cluster for you. So that's where we're headed. But I want to first spend a lot of time thinking about how we get to those 3 lines and what they do under the hood. So let's dive in. Let's start with an example. Let's say that you are a data scientist and that you want to use pandas and XGBoost to train a model. Okay. This is really accessible today due to a lot of great work in the community. You can do things like conda install XGBoost and pandas onto your laptop. You might download some data set like the Higgs boson training data set from Amazon S3. You would then start up IPython, Jupyter, a Python script. You'll import your libraries, load a CSV file. There's probably some feature engineering here I'm skipping over. Then you're going to train that model with XGBoost. And this is actually a really accessible workflow. This is why we love PyData. Anyone in the world with access to a laptop and some time to learn can do this work. And that is an incredible testament to what we have accomplished. Now, if you're trying to do that on larger data sets, things can get a bit more complicated. Now, maybe you've seen some documentation, you go to the pandas docs, the XGBoost docs, and you're curious about how to increase scale here. Both of those will mention Dask. Dask is a popular library for parallel computing in Python, which integrates with lots of popular Python libraries today. Okay, so you add Dask to your conda install commands, and you switch out pandas for Dask data frame, and you use the XGBoost Dask model, or XGBoost Dask module, rather than the XGBoost module. This works just fine on your laptop or on a workstation. This is also really accessible. It might require a little bit more time to learn, and there's some extra complications here, but this is, again, still a very accessible workflow. Anyone in the world can do this. There's not a lot of complication here. Where things get tricky is when you start going to multiple machines, especially machines that you yourself do not own and control. And so you might extend this process and use a library like Dask Kubernetes. Maybe you have a Kubernetes cluster at work. Maybe you're just excited about Kubernetes. So you're going to import some project like the Dask Kubernetes library, get the Kubernetes cluster object, and use that to connect to a Kubernetes cluster. But now wait a minute for a second. This requires some more setup. You need a cluster, you need to authenticate it to it. We're now going directly to S3 with our Dask workers. So there's some more setup here that needs to be done. So let's go and dive in and see what it is we needed to do to set that up. So the first thing you might do is you'll probably do a web search, right? Maybe Dask on the cloud. That will link you to our documentation on Dask cloud deployments. It's a great starting point. When you go there, you'll see that there are a few different options. You could use something like Kubernetes, and there's a whole documentation page on the different options of Kubernetes you might choose. You might also choose something like Yarn. Something like Amazon EMR is really familiar to a lot of people who've come from the Spark world. That's also a great entry point. You might also use something like Dask Cloud Provider. This is actually my preferred way as an individual to launch Dask on the cloud, other than Coiled. And you might try that instead. But many people today try Kubernetes, so let's go down that route. Let's say you click on that link. Okay. What you'll find first is that you need to set up a Kubernetes cluster. Probably you work somewhere or you're a student and your workplace or university has access to a cloud account. You're probably going to ask your IT department for credentials, and they'll probably give them to you. They'll probably email you a CSV file with a secret and key. But they're going to do some work on the back end to make sure that works. Then you're going to log into Amazon, Azure, Google. Here I'm using AWS just because we see it come up the most often. But the workflow here is kind of the same on any of the clouds. You'll probably look at the Kubernetes service attached to that cloud. In Amazon, it's EKS, and you'll create a cluster. You'll specify some things like node pools and how big of machines you want to use. But this is pretty straightforward. You can point and click on this if you're not too turned off. You probably also need to install something like kubectl to control your Kubernetes cluster. This isn't strictly necessary, but it'll end up being helpful. You're going to want to clean some things up, add some things, inspect what's going on. So you're probably going to curl this down, modify it a little bit, and run it. Docs here are pretty extensive. This is probably not something that you're familiar with, but you can be. And this is, again, good training. Maybe you're enthusiastic and you want to learn. So you set up your Kubernetes cluster. We're now ready to run our script again. There are some things you're going to want to add into this Kubernetes cluster object, which I'm kind of skipping over. But there's some setup, some configuration. You'll be okay. The documentation, again, is pretty good. So you set that up, you run your script, and you get a module not found error. So this is the first IT problem we're going to run into, other than just setting up our Kubernetes cluster. And what you find is that you don't have XGBoost installed. That's confusing because you've already installed XGBoost. It turns out that errors like this are coming from your Dask workers. Even though you have XGBoost installed on your local machine or on some notebook you're running in the cloud, you actually don't have that installed on all of the containers that you're running on Kubernetes. So that's not a problem. You can go and build a Docker image, right? And so maybe you go look at the Dask Docker images. It's a good starting place. We do lots of nice things in there, like clean up excess packages, sort of try to reduce the Docker image size. And you'll change around the packages there. You'll add maybe XGBoost, and then you will maybe make a Docker Hub account. You'll build that Docker image and push it up. If you don't have Docker installed, you might install it. Linux and Mac, you'll probably be fine. So we start again. We now have changed our configuration in that Kubernetes cluster. We're using a separate Docker image that we've already created and pushed up to the cloud. We're ready to start again. So we run our computation and there's an S3 permission error. So this is awkward. We didn't get this originally on our laptop. That's because we actually had credentials on our laptop. But our Dask workers on our Kubernetes cluster don't have those same credentials. Those pods, those containers don't look like us. They don't have the same credentials that we have. And so if the dataset that you were trying to read isn't publicly accessible, or if it requires some sort of authentication in order to download, you're going to need to somehow figure out how to distribute your credentials onto your Dask workers on your Kubernetes cluster. The sort of hacky way to do this is to use Dask itself. Dask provides mechanisms to upload files to all of your workers. This will work, but please don't do this. There's lots of reasons why you shouldn't do this, and we're going to get into those in a second. But let's say you've done that for now, just to get things up and running. You've propagated your AWS credentials to all of your workers so that when they run AWS commands, they look like you. AWS knows that it's you trying to do this work. So we're ready to try our script again, and it actually works. This is amazing. You have trained an XGBoost model at scale, and this is super exciting. At this stage, you are thrilled. You're seeing lots of work happen on your cluster. You can scale it out, you can scale it down, you scale up to 20 terabytes of memory, and you start doing lots of different things. This ends up being actually a great time for you. You have the tools now to scale anything. Remember that Dask integrates with tons of different libraries, and so you can do tons of different kinds of workflows. And this just adds a new tool to your toolbox that you can combine with all of your pre-existing tools. So it's, again, a very exciting time. You can scale out, And you can control hundreds or thousands of machines from anywhere. And that's really fun. You can even try GPUs for a little bit. This will end up being awkward for other reasons. You're probably not gonna want to do this. I'm gonna point you to a talk I gave recently at NVIDIA's GTC conference, which talks about some extra challenges for GPUs. We're not gonna go there for now, but is maybe a small plug. So again, things are good. You're really happy right now until IT finds out. So you're gonna get an embarrassing email from IT. They're gonna ask lots of questions. They'll say something like, we've been checking our pricing logs and you were apparently spending some many thousands of dollars per month. The actual work that you're doing is fine, right? The work that you're doing is generating value. It's worth the money that the company is spending or the university is spending on that compute time. But the majority of your costs actually aren't coming from your work. In your early experimentation, maybe you left up some idle clusters and they've been running 24/7 for some time. Also, some of the early experiments that you ran created extra resources that you weren't really aware of, like networking issues or load balancers, and those have remained active. Anybody who's played with the cloud long enough has been hit by this. You will too. It's fine. Another issue, IT, now that they've become aware of this topic because of the cost issues, they start looking at your system, right? And they're sort of curious about the system Dask that you're running, which allows for the execution of arbitrary Python code on hundreds of machines inside of their network. And this raises some security questions. One thing that comes up is that you probably didn't implement something like TLS security. You're probably not using certificates. And so anyone, if they knew the address of your schedulers, could run as you inside your network. Fortunately, this hasn't happened, but it's something you should be aware of and probably not do in the future. You're also sending sensitive company data along unencrypted connections, to and from the Kubernetes cluster. For example, remember those AWS credentials? You might have sent those over the open internet, so anyone along the chain from your laptop to the cluster could have read them. Again, they probably didn't, but it's the kind of thing you probably don't want to do. Those AWS credentials also allow for impersonation. So it's likely that at this point, you've been successful enough that you showed this to your team, and they were also very excited. You've probably given them access to that cluster, but they might be operating as you now. They need to manage their own credentials on those Kubernetes clusters. And this is again, fine, but IT would prefer that you didn't do that. So fortunately, nothing bad happened, but you now need to be a little bit more careful. And this is good timing because again, your teammates all want to use this same system. They want the same power that you've had over the last few months as you've built up this capability. So this is again, really good timing. And you're also now in charge. You're the only person in your group that understands both the data problems you're trying to solve and also enough of the sort of IT cloud DevOps problems to control things. This is either great or terrible. If you want a career change, this is a great one. There's lots of money to be made here. Or maybe you just wanted to be a scientist and this maybe isn't great. As a side note, putting on my sort of for-profit hat for a second here, a lot of Coiled early customers have gone through exactly this trajectory. They're data scientists who are really high performing, figure out the cloud just enough. And then as they get into it, they realize, ooh, this is more than I wanted to handle. Or even something that they're excited about. They're spending a quarter or a half of their time handling this stuff. And it's not really cost efficient, right? Maybe they're spending $5,000 a month on cloud costs, but their salary is $10,000 a month. And so this just doesn't quite make sense. It's a lot of work. So let's go back in time and try a different approach. This is again, we're gonna get a little bit into the sort of sales pitch here for a second. So we're not going to solve kubectl. We're not going to create a Kubernetes cluster. We're not going to, we might still ask for a role on the cloud from our IT department. We're not going to go through different options. What we're going to do instead, we're going to try Coiled. So again, putting on my sales hat here for a moment. The Dask maintainers have seen this happen many, many times, this exact same path. Some of us actually made a company to automate that process, and that company is Coiled. We started in February of this year, and it's actually been a really exciting growth to see people jump on. We try to make it easy to run Dask on the cloud or on other infrastructure. The the punchline of this whole talk is to try running pip install coiled, and then import coiled and create a coiled cluster. And this will do everything that we've talked about for you in a safe, secure way. Let me actually just go and do that for a second. So I'm going to open up IPython. I'm going to import coiled. Let me see if I can bump that up a bit. And I'm going to make a coiled cluster. Now, what this is doing, this is launching a bunch of resources on the cloud in a nicely authenticated, secure way, handling everything we just talked about. It's going to take about a minute. The cloud, we can get machines in about a minute. That's sort of as fast as we're able to go right now. I'm going to jump back to slides, and we're going to come back to this in just a second. So the main goal of Coiled is to launch Dask clusters for you. It does lots of other things, but this is the main objective. In the background, we're using low-level cloud APIs to provision cloud resources on the fly. We actually are not using Kubernetes because that would require a different infrastructure. It doesn't allow us to be quite as global. We're going a little bit lower level to give you a bit more access to running anywhere on the earth, in any cloud, and also to be very fast. We spin up resources in about a minute today. And this is fun. And this, again, does everything that you need. And it handles everything for you. Let me jump back to our machine here. So we can see here a few things. We can see, again, I'm still running, I'm still creating things. It looks like I've asked for 4 workers by default. I can also see some historical workloads here. I can see that I've recently, I think just actually before running this talk, I was going through a dry run. We can see what I was running before. That I, created a different cluster that was costing about $2 an hour, and a total of 40 cents. Looks like our cluster has come up. No workers have arrived yet, but that's okay. We can get started anyway. So I'm going to connect to that cluster with Dask. And there's an interesting warning here, which we're going to get to in just a second. Let's go and look at the dashboard for that cluster. Let's pop that up. And so now if I want to, I can import any Dask library, like maybe Dask array, and I can start making some resources. So here I'll make looks like this is a 16, 18, 20 gigabyte Dask array, and I can compute the sum of that array. And so this is great. This is normal Dask things. We can go ahead and scale up. This will again take about a minute. That's about our response time on asking for resources. But I can import Dask data frame and go through other Dask computations. Anything I could do with Dask, I can now run with Dask on the cloud at scale in a very comfortable way. So this is a lot of fun, and we're going to get back to this example a little bit as we go through slides. I want to talk about what's happening under the hood and what are the different kinds of situations that we run into that we're going to need to solve. And we've seen those before in our previous example, right? We're going to need to install libraries. We're going to need to figure out security. We're going to need to figure out authentication. And all of those things are happening for us right now automatically. So the first of those is managed software. How do we add the libraries that we care about onto our Dask workers on the fly? And how do we share those around? How do we version them? There's a lot of sort of social things that happen with these software libraries. Many of our users don't actually understand Docker that well. A lot of data scientists have some Docker familiarity, but it's not a tool that they use on a daily basis. So this is one of the things that we handle for you. You can register software environments with Coiled. You see a screenshot here on the left. And Coiled will solve those for you. It will build them for you. And it will also allow you to conda install them on other machines in the future so you can sort of match that sort of remote and local development experience. We're actually seeing that a little bit here. Notice that Dask is actually complaining a little bit about different versions between my laptop experience and my deployed experience. Looks like actually on my laptop, I've got a development version of Dask running. That's okay, but Dask is making us aware of that. And if I want to keep that in sync, Coiled gives me the tools to do so. It looks like, again, about a minute through our computation, more workers arrived, and we can go ahead and do some computations. So again, the first additional step software management. And if we go in and look at Coiled, we can see that I actually have a lot of software environments that I manage, right? That I've been using in my experiments, and I can use and deploy those as I want in the future. So moving on, Coiled lets you run in a very flexible development environment. So I want you to notice that when I was running that example over here, I'm actually, the left side of the screen, I'm just running IPython on my laptop, right? I can run Coiled from anywhere. Coiled does host notebooks. You can run notebooks on Coiled, but we don't force you into that experience. A lot of our users actually already have a notebook solution, or they want to work from their laptop. Maybe they've got PyCharm or VS Code set up just the way they like it. Most of the time that Dask users develop code, they're actually not using Dask. Dask is used only sort of when you need to scale. We want to try very, very hard not to force you into our development environment. Instead, Coiled tries very hard to come to where you are and work within your development environment. So this means that Coiled is publicly accessible. The clusters that you run can be accessed from anywhere, assuming that you are authenticated effectively. And that really allows for a lot of new applications. You can use Coiled from AWS SageMaker. You can use Coiled, again, from your laptop, from any IDE that you have running. You can use Coiled from automated scripts running on Prefect. We really tried to decouple the development environment from the compute environment, and that's been actually really exciting. It opens up a lot of very fun applications that weren't available before. Third, cost management. Again, in that scenario where you become the DevOps person, you end up having a team that all wants to run this same system, and some of those team members are going to be really on top of things, and some of them aren't. They're going to be new, and you're going to want to be able to manage and shape and control their usage, and also track their usage over time. And so that's why Coiled provides things like cost metrics, right? I can see that my cluster has cost us 15 cents so far, and I can track this not just with my workloads, but on anyone in my team. So, in my particular team, there's only me. But if I go to maybe the Coiled account, there are actually a variety of team members that I work with that are working on the Coiled team. And we can control things like the core limits. Maybe Marcos here has been, he's been pretty good about costs. We can increase his limit up to 500. And these sorts of quotas and cost tracking and cost limiting are actually really critical in an organizational setting. Coiled does lots of other things to manage your costs. Again, we track usage per user and per team. We also do common sense things like shutting down idle clusters after 20 minutes by default. There's no more leaving clusters on over time. We scan for idle resources in case anything has been missed, and we clean them up. We provide toggling for things like GPUs. We also, again, provide GPUs. We skipped over this when we were going through the XGBoost Pandas example, but GPUs can be amazingly powerful and amazingly cost-effective in the right situations. You might be aware of some of the sort of Dask-friendly GPU libraries like Rapids or PyTorch or XGBoost or Blazing SQL, and you might have seen some of their talks and you want to try it out. Handling Kubernetes on the cloud is doable if you have some gumption. GPUs end up being a whole other level of complexity. We work very closely with the NVIDIA Rapids team to make sure that this is smooth. So Coiled can provision GPUs for you. We also provided a lot of pre-configured software environments that you can use and modify. This ends up being actually really critical. It's challenging sometimes to get the NVIDIA CUDA drivers to match with the right Conda environments, to match with the right software packages, and deploy those all effectively on the right instances. Coiled makes that pretty easy. We also handle security. So for individual users, this usually isn't so much of a problem, but you're still getting the same basic best practices that we give to you. My cluster over here is network secure. We're running over TLS, you're authenticated. All the information that you're sending up and down is well taken care of. You can operate in confidence. Additionally, for larger groups, you can also run Coiled inside of your own infrastructure. you can provide us with AWS credentials to manage things in your cluster, and we'll launch resources there. Coiled also works, on other systems. We have sort of basic experimental support for Azure right now. It's October 2020, as well as a bring your own Kubernetes approach. So Coiled can deploy and manage resources on other systems. We are AWS first, but lots of other systems are available. We also work on any region. Again, we are choosing technologies that allow us to be a little bit more native than a Kubernetes cluster. We're running anywhere that AWS runs in a nice way. So I'm going to sort of finish up here for a second with some high-level thoughts. Coiled was designed to solve human and organizational problems in the same way that Dask was designed to solve algorithmic or technical problems. So Coiled is free for individuals to start. You can run everything I just ran for free. We're in beta up to sort of 100 cores of concurrent usage. Please try it out. Again, pip install Coiled. You'll be good to go. We provide pre-configured software environments. There's lots of examples in Coiled that you can run that show lots of very cool Dask usage at scale. You can also drive from anywhere. You don't need to pick up your development environment and move it to Coiled. Coiled comes to you. And that's something that we really care about in terms of ergonomics. We are there when you need us, but we get out of the way very quickly when you don't. So again, you can be running with Coiled on your data, on your hardware in a few minutes. We tried very hard to make that on-ramp as easy as possible. Additionally, you might be trying out Coiled because you're a student. If so, great, enjoy. You might also be trying out Coiled as a possible replacement for your, maybe you've gone through that same path that we talked about. You set up the Kubernetes cluster, you no longer want to be maintaining it. And so you might be using Coiled just to try it out, to see if it's a good replacement for what you want to do internally. And again, Coiled scales with you. Coiled runs both with individuals and with some of the largest financial institutions in the world and with government groups. So we can deploy it on your infrastructure. We can provide, manage users, teams, and quotas. We also track everything that's being run and can give you a lot of sort of drill down information on how much money did you spend parsing CSV files last quarter. A lot of this stuff ends up being really, really useful as you get up to larger and larger organizations. And again, Coiled is built with best practices. The creators of Coiled have deployed, I don't even know how many Dask, and I don't know how many companies so far, but we've done this lots of times. We're very good at it. And the tools that we're building make it very easy. So if you're interested in running Dask inside of your organization, Coiled might be a good fit. So I'll leave you with that call to action. Try it out. You can, again, get a cluster running in the next few minutes. And yeah, come check us out either at dask.org to learn more about Dask or coiled.io to learn more about deploying Coiled. And that's it. Thank you all for your time.